Welcome to 90 Notes. Today's topic, well, it's depreciation. Depreciation on that car that you bought. Now, I like to call this the 2020 exercise because we're going to start with a car with a value of about $20,000, hypothetical value, and we're going to, well, express its depreciation over 20 years. Now, this is a hypothetical exercise. If you're a car dealer, you can. This is the wrong exercise. This is a high school math class. Come on. This is so you understand the concept. The class you're in right now is financial literacy. If you are if you are here in the time of COVID, you're watching this on Zoom. If not, maybe you're watching this, maybe you missed class and the in-person live class in a subsequent year, and you're watching it, and you're watching it on YouTube just to catch up. Either way, it's all the same. So we're going to do a little bit of an exercise here, and we're going to use this industry average that a vehicle loses 15% of its value per year. So that's an annual basis. And yeah, I know. You can tell me it's not always that way. And some people say, well, it loses 20%. You take it off the lot, and then 15%. Then some of you say, well, my car's, Mercedes-Benz. It doesn't lose that fast. Well, that's okay. This is just a model. You guys figure out your own car. But for here, we're going to learn the math. That's why we're here. Now, we're going to just go through the very basics. For example, if I start right there, I could take, if I'm going to take 15% depreciation, $20,000. Take away 15%, that's 0.15, that's $3,000. I can then take my $20,000 and subtract $3,000, and I'm left with $17,000. Well, that makes a lot of sense. If I were to graph that, that's going to be right here on my graph. That's not showing up very well. So I think I've got a little tools here. Where is that thing? Yeah. Maybe I'll put that on there. So those as my two data points. So I'm going to say that in the 0 year, it's worth $20,000. 1 year hence, it's going to be worth $17,000. Pretty easy. Now, if you're in my Zoom class, you're thinking, hey, I don't have that grid. Well, that's okay. You can do this. You can do all these calculations. We're going to do these manually. You can sketch this. If you have graph paper, you can make this. You just need a 20 by 20 grid, or you can follow along and you can kind of sketch it freehand. And let's see how well you can do. Now, this is kind of a tedious way to do things because, I'm taking 15% and I'm subtracting it. Why don't you just do this? Now, since 15% taken away from 100% leaves me with 85%, just take your $20,000 times 0.85, right? 15% is going away. That means 85% is staying. So it retains. Well, I guess that's the optimistic way. And all this, if you are losing 15%, you're retaining 85. Yeah, I like that. So, I suppose I could put this over here. I could put this right there and say, yeah, there's my $17,000. So we can finish this chart. And this will be a piece of cake because you're just going to take that number. Where's that calculator at? Let's take this calculator. So we've already got 17,000. And all we have to do is keep going times 0.85. Oops. Oh, bad banish. 0.885, I said. And that's going to equal. Yeah. Okay. So we can just, and then we're going to multiply that again. times 0.85. And we're going to record the next two numbers. So you see how this works. We can just go down here. And so that's going to be for year number 2, year number 3. And let's put those up there. Now, if you're trying to graph them, year number 2, well, if this represents year number 2, and I'm trying to get 14,450, this is 14,400, this is 15,000. I guess it's going to be in between there. So you're going to have to, you're going to be able to do that. In the same way, 12,283, I'm looking at 12, 13, it's going to be between there. And it's going to be on this, on the line, on year number 3. So you're just learning how to graph. Represent that. 283, that's going to be, well, I guess that's going to be about a quarter of the way from here to here. So go ahead and do that. Yeah, that looks good. And then we're going to do this. I'm just going to put these dots, make them a little bit bigger so it stands out. All right, where's my calculator? Where'd that go? I'm going to come back to here. I'm just going to keep this thing going, times. And I'm going to say 0.85. 10,440, write that down. Times 0.85 again. No. Jeez, I keep doing that. 0.85. Wow. Let's go times 8.85 again. Times 0.85 again. Are you getting those numbers? I hope so. Times 0.85 again. Well, gee, I lost track of how many we did, so I think we did these. So let's do this. Whoa, hey, that's slick. So these are the numbers I got. You know, I'm not going to write down the pennies because honestly, that doesn't make sense. And go ahead and, if you were graphing these, how is it going to look? So you're going to go to year number 4. Year number 4, 10,000. Wait a minute. So it's just a little over half, or it's lost almost half of its value. Yikes. Year number 5, 88.74 is about there. Year number 6 is going to be there. Year number 7. Now, year number 8, let's come down to year number 8, and we're looking at 5,450. There's 5, oh, wait a minute, I guess I skipped year number 7. Oh, I'm bad at this. Year number 7, 6,412. This is 6,000. This is 7,000. Just a little over halfway. a little under halfway. 412. Here we go. Year number 8. And look what happens. Year number 9 is going to cross below 5,000. And you're starting to get this very interesting shape. So let's color these dots in. Why? Because it's fun. Now, in your math class, you can say, hey, that is non-linear. Yeah, because it sure don't look like a line, does it? Because it's not. Now, if you're in my class, I mean, you probably found there's a better way to do this, but if you didn't, you just keep taking that number times, what did you leave off anyway? Oh, yeah. You just keep taking that times 0.85, and you just keep going. And we're going to go all the way to 20 times 0.85 times 0.85 times 0.85 times 0.85. Wish there was a better way to do this. times 0.85. Oh, this is exhausting. Times 0.85 times 0.85 times 0.85. Oh, I lost track. Ooh, 911. We're way down there. We're below $1,000. And honestly, this is where you're going to have to remember, we learned this thing about domain and range, because this graph is only going to make sense for a certain range or domain of values and within a certain range. When it gets down to beyond 20 years, it's going to cost more to maintain that car. I guess you're probably driving on the maintenance at that point. Hey, let's fill in the chart. Let's just see what it looks like. Display, show labels. Boom. Well, there we go. Oh, there was the 9. I guess that we made it to 19. Oh, stop. And let's fill them in a little bit at a time. And you can see, if you were doing this manually, check this out. Look how flat the curve gets down here at 14 years. At 15, let's look at the chart. 15, 17, 1,000, 747. I like that. But it's below $2,000. And you keep going. And there it is. Wow, you did it. Congratulations. You made a beautiful, beautiful, beautiful graph. Now, if you were in my in-person class, of course, what you would do, you'd hand a paper in. But this is the time of COVID, and you're in a Zoom class, and of course, you're going to scan it or take a picture of it with your phone and upload it and all that. But we're not done yet. We are not done. We're going to learn some shortcuts, because this seems kind of tough. Like, if I want to find out at 15 years, I got to do this 15 times. There's got to be a better way. And your key, that it's right there. And that's the vocabulary word of the day. Exponential decay. So let's move on. Let's take this topic and let's express something this way. Exponent, if I keep multiplying, I keep multiplying by 0.85. Remember, 85% of the value stays year to year to year. Remember, this is a math class after all. So what is one way of looking at it? Well, the base is 0.85. In exponential notation, the base is that value which you multiply over and over and over. You keep multiplying times 0.85. So I'm going to write my equation this way. The value of the car is $20,000 times 0.85 to the nth power. So you see, we can skip, right? We don't have to go one at a time, like 1, 2, 3. We don't have to do that. No. We can do it the smart way. You can just type in n is the number of years. And let's do a hypothetical example. And that hypothetical example is, let's suppose n is 10. Because I want to say, hey, what's my $20,000 car going to be worth in 10 years? Yeah, good luck with that, but let's do it. We're going to take this, let's clear this bad boy out, and we're going to say, let's just take this car, because imagine we haven't done the graph. And we're going to take 0.85, because that's our base. And we're going here, y to the x power. That's where we raise it to a power. And we're going to raise it to the power of 10 equals, ooh, you know what that says? You can interpret that right away as saying, dang, it's under 20% of its value, just under. But I'm going to multiply that times my original principal. In this case, that is the coefficient. Coefficient. Ooh, I like that word. So we're going to put in the $20,000. And heavens to Murgatroyds, look at that. You get 37 or 39.37. And what did you have right here? Boom shakalaka, 39.37. You got the same thing. Of course you did, because that's how it works. That's math. And that's the power. That's the power of math. That's the power of understanding your equations. Hey, let's do another one. Let's do it. Let's do it again. Let's do it backwards. I'm going to ask this question. I ran out of room. So here I'm going to say, how about this? At what point in how many years, N, in how many years will my car decay all the way down to 10 grand? Now, I moved this up here so we got a little bit more room. And we are going to solve now for N. That's the number of years. How long does it take for my car to be worth, $10,000? Well, we could just look at this graph, but suppose we didn't have the graph. We didn't do that. We just want to demonstrate that we could, we know we could put in a value for N and get the value of the car, but can we go in reverse? Of course we can. Now, this is going to take a little bit of a trick. Well, okay, the first part's easy. Let's just divide both sides by 20,000. I could have just said, well, when is my car going to be worth 50% or half its value? See, and now we've gotten rid of the coefficient in our equation, that $20,000. So you could just say we're solving for a percentage. When is a car at half value? You chemistry folks are thinking, half-life of my car. Interesting. So this is where you're going to bust out your calculator and say, dust off your logarithms. Yeah, golly, this is, you hardly ever use these, but they're so cool. So what we do know, that the inverse operation to exponential notation is the logarithm. So what we're going to do is we're going to take the 0.5 and we're going to take the log of the base, 0.85. Yikes. All right, let's just do it. Watch. Now, oh, heavens to Murgatroyd. Look at this. I'm lost. Oh, I've got to hit the second function. See, because I don't want a base 10 log and I don't want the natural log. I want, oh yeah, I want a log where I can put the base in. So watch this. We're going to take in 0.5. And I'm going to say no, I'm just going to say 0.5 log. Oh, no. Okay, try that again. 0.5 log 0.85 equals, boom, shakalaka. Oh. All right, let's do that again. So I got to stop messing up. 0.5 log 0.85 there. 4.27 years. Wow. And let's have a look at that. That's going to be right there. Pretty cool. So that's 4.27. And you can see that that's where it would cross through that curve if we put in a continuous curve there. Look at that. Hey, that's kind of neat. 4.27 years. It's like the half-life of your car. Now, again, we could have just looked at the graph for that. But this was kind of cool. Now, if it stands to reason that, well, we did it for half value or 10,000, we can do it for any value we want. When is my car going to be worth my $20,000 purchase? When is it going to drop down to $4 grand or 20%? Well, I'm just going to express it as a percent and get rid of that 20,000 right away. You see now, I can solve the exact same way. I'm going to pull this out. We're going to clear. And we're going to say 0.2. And let's put the log 0.85. Look at that, 9.9 years, just shy of 10. Let's check it out over here. There's my 10-year, and you can see I dipped just below $4,000. So 9.9 right about there. In other words, it works, and that's so cool. Now, when you get all this done, yeah, you can take a picture of that. You're going to send it in. And as the old saying goes, but wait, there's more. You know, we're doing it the hard way. Anybody want to do it the easy way? Okay, well, this is manual, and I think this is pretty fun. And again, if you're in the live version of the class, certainly you're going to be doing this. I'm going to hand out this paper, and you're going to plot by hand. But you know, you guys and if this is a Zoom class and you sketched it, you can't really get that beautiful curve. So we're going to make it more pretty. And we're going to start all over again from a blank slate. Ready? Tabula rasa. Here is our blank slate. Okay, so you opened up a blank page here. You've got your, we're going to go to our little Google Apps and Sheets. Now, for those not in the Anchorage School District, start a new spreadsheet. We are using this. Well, this is what we use because I know we got this. Sure, you can use Excel or any other spreadsheet application that you got handy. We're going to go with this one. And we're going to reconstruct the chart the exact same way. Well, actually, hang on. I'm going to zoom in just for, and we'll zoom back out later on, just so you can see a little better. And in the A1 cell, I'm going to write the year. And I'm going to write for value for my title. And then maybe over here, somewhere I'll write my name. Yabba dabba doo. So we're going to start at year 0. And we're going to start with $20,000. Okay? Both of those are numbers. We're going to change it up a little bit. First column, take that first column, I'm going to center it. Why? Yeah, because I think it'll look good. The value, just this cell, maybe I'll center that. But the dollars should be right justified, and they also should be dollars. So I got the B2 cell, go up here to the money. Now that's the money. I wish it were that easy. All right, I'm going to number the years. So we got this on, and I could number 1, 2, 3, 4. But I can do this, equals cell plus 1. You might say, why'd you do that? Well, because now I can copy this, Command C, and I can sweep down there. Oh yeah, nice. And actually, let's just keep that going. Now, we'll change the scale back later when we need to. Look at that. So we've got our years, 1 through 20. The same thing. We said depreciation. Depreciation, 15%. We're retaining 85% of the value. This is the operation of multiplication. Equals. And we're going to say MULT. Multiplication. I'm going to click this cell, comma, 0.85. Just like we got before, $17,000. Now, what is different here, and I'm going to go back to this view so we can see all our data. Now watch this. Because it's a spreadsheet, Command C, I'm going to sweep down to here, Command V. Heavens to Murgatroyd, it's just what we got before, all the way to 775. Now, I'm going to do this. Make it look good. And maybe I'll make this. Like we've done before, I'll make a little header stand out. We're almost done. Isn't that easy? Why didn't we do this in the first place? Well, I don't know. Teachers, we like to make you suffer. Hey, one of the things I want to point out that maybe you didn't have a $20,000 car. Maybe you went upscale and maybe you spent $35,000. And you see, well, because you did it in a spreadsheet, it'll just, you can do it and you can put any amount in there. Okay, we're going to go back to the 20 because that's what we put in there in the first place. All right, now we're going to graph this one. And it's this cool. We're going to click on, you got the A1 cell, hold down until you're all the way at the bottom here, which I guess is the B22 cell. And you're going to go insert. You can pull insert chart, or you can actually click over here. This inserts a chart. Either way. It's making that chart. Oh, beautiful. Look at that. You can resize it a little bit, make it like that. And maybe you can do a few different things to it. Gosh, I set up rows, customize. Oh, grid lines and ticks. I think this is what I want. So maybe I want to be able to see, let's go vertical. The minor count, I think, would be 4. 1, 2, 3, 4. So it's 1, 2, 3, 4, 5,000. What kind of like that? And let's go horizontal axis. Would it be 4 as well? Yes. So now I can see the years. 1, 2, 3, 4, 5. Oh, that's beautiful. It's all lined out like that. You're done. Send that in. So, okay, this is back to the how to send it in. Do not hit the share button because you know I'm not going to get this. If you're in my class, you're sending this to me in Canvas. Maybe some other teacher wants it that way, but I want you to do this. Command P. Go to print it. Yeah, it's going to fit on the landscape. That's good. You hit the next, and it says, where do you want to print? Well, you're saving it as a PDF, of course. And you can hit save. And then you're going to say, Fred's Depreciation. Curve. Or, yeah, that looks pretty good. Save it to the desktop. And you are done. Well, you're done. You're going to have to end. You're going to have to close out here and then upload it to Canvas. Remember to turn in the other part of the assignment, the part you did by hand. And you got these 2 things done, and we had a lot of fun, and hopefully we learned some math. So thank you for watching Nani.